Good day, guys. I hope you're all doing so well. So namhlanje we're gonna deal with a hyperbolic function. But before that, don't forget to subscribe, like, and share for more content on this channel. Yes. So hyperbolic function is so simple. Its basic function it's a general equation. It is y equal a over x minus p plus q. This is the general equation of hyperbolic function. This one you did it in grade 10 perhaps, where we don't have p and q as such. We only have a over x, where the value of p and q are zeros. I will explain it in the next example, by the way. Now, the value of a over x minus p plus q. Remember, the value of a, when it is bigger than 0 or when it is positive, it also determines the shape of the graph. So when the value of a is bigger than 0, our graph is going to be on a second quadrant and on our third quadrant. When the value of a is bigger than 0, then when the value of a is smaller than 0, when it's negative, our graph is going to be on our second quadrant and our fourth quadrant. Then you are done with drawing the graph of this function. This is how it looks, the graph of hyperbola. It always reflects. It always reflects. Yes, that's how we draw it. That's how it is all the time. Then now we're gonna deal with asymptotes right now. Shifts of set of axes. That's the meaning of asymptotes. Meaning on this graph we have asymptotes, both vertical and horizontal. The value of p, it is our vertical asymptote. Meaning in this case, the value of p is equal to 0. In grade 10, the value of p is equal to 0. In grade 10, the value of q is equal to 0. This is our horizontal asymptote. Hence, this graph does not touch the y-axis and the x-axis line, because the value of p is 0 and the value of q, it is 0. Here and here is x plus 0 plus 0, our q. Simple, guys. Now, asymptote determines the shifting of the graph, meaning when the graph it is vertical, it shifts from left to right. When our graph is horizontal, it goes up or down, meaning the graph, if the value of p is equal to 1, that means our graph is going to move 1 unit to the right. If the value of q it is negative 2, our graph is going to move negative 2 downwards. Simple, meaning our dotted line. How do you see the asymptote on the graph? Let me just draw a Cartesian plane here, guys, so that I can elaborate more on the visibility of our asymptotes on our graph. The value of p perhaps is equal to 2, meaning 2 is going to be on the side here. This is how it looks like, our asymptote for vertical asymptote. Then your graph, then the value of q it is negative, or negative means it's positive 1, the value of q. Our horizontal asymptote, the value of q 1 is going to be like here. Then perhaps let's suppose let me just draw the graph basically. Let's say the value of a it is bigger than 0, meaning our graph is on the second quadrant. On our first quadrant and our third quadrant. That's how it look. This is how it look like. This is our graph, guys. It won't touch the x-axis line, but it will pass next to it. This is how it will look like. Can you see it, guys? It determines the shifting of the graph, vertical and horizontal. It has shifted 1 unit up and 2 units to the right. Simple. You are done with asymptotes. Then remember asymptotes, if you have let's come back here. Meaning asymptote, the value of p changes the sign. When it comes out of this equation, we have x minus p. So this p is going to change. If it's negative, then it's going to be positive when it comes to the graph, the value of p. So the value of p, if it's negative here, is going to be positive when you draw it on the graph. When it's positive here, vice versa, negative here. How do you find the value of p? We want to say x minus p equal to 0. Then x is equal to positive p. Or negative p, positive p. The final answer is positive. Even here on this 2, if we have perhaps x minus 2 on the graph, if you have x minus 2 here, you want to say x equals to 0, then x equals to 2. Then you're going to plot this 2 on our graph as our asymptote. Then you are done. I hope, guys, you understand it. Domain and range. Number 2, domain all x values that are real such that x is not equal to p. Let's come back here. Domain, it comes from our denominator of the hyperbolic function. meaning from x minus p, that's where you find our denominator. Meaning, I get what's about graph when it touches, it does not touches our asymptote. Hence we say x should not be equal to p, and this p, it changes sign also. Remember, x minus p equals to 0, then x equals to p. This p, it is our denominator domain, meaning x should not be equal to this when you come here, because when it equals it is undefined when the graph touches the value of p. And here the graph will never touch the asymptote line, the vertical asymptote line, because when it touches it's going to be invalid, or it's going to be undefined. Hence the graph will just pass next to that line up until infinity. Even on our horizontal line, it's going to pass next to this asymptote line up until infinity, but they don't touch it, but it will pass next to the line. The graph will pass next to that dotted line. That's hence we say x should not be equal to p. You can just apply the equation. If the same as determine the domain of this function, just say x minus p is not equal to 0, then x is not equal to p, then this is our domain for this function. Then when you want the asymptote, you just say x minus p equals to 0, x equals to p. You must not write it like this. When you want asymptotes, this is when you want domain. Asymptote, domain. Asymptote, domain. When you say domain, you say x is not equal to 0. X minus p is not equal to 0, therefore domain x minus p equal to 0 for asymptotes. Yes, asymptote, yes. Then for our range, y is element of real number such that y is not equal to our q. Our q does not change the sign, it stays the same. If positive is positive, there's no change of sign. If negative is negative here, it will never change the sign. So just say our y is not equal to the value of p, the value of q, running, because our graph will never touch this asymptote line, because when it touches it, because the asymptote line is it is where the y value is infinite. It is where the y value, it is undefined. That's where our graph is not found. That is where our graph is invalid. That's where our graph it gets to be limited from touching or passing through that dotted line. Hence say y should not be equal to this line. Y should not be equal to 1, simple in this graph. Y should not be equal to q for this equation. Hence we say this. That's how we determine the range of this function. Then let's come to axis of symmetry for this function. Axis of symmetry is so simple. We have got negative symmetry and positive symmetry. Let's come back here. For this graph, we have, can you see these dotted lines? This is our axis of symmetries. So you want to draw it when they say you must show the axis, if they say you must determine or must draw the graph with axis, you must draw these dotted lines. This is not our asymptotes, this is our axis lines. This is our axis of symmetry, and they are straight lines, they are linear, hence we've got equations. In this graph, the positive axis of symmetry, it is y equal to x for this one. This is the axis of symmetry for y equal to x. When it is positive, then when it is negative, this is the one we use for negative x. This is the graph. Basically, axis of symmetry, it means that this graph, this line touches the graph into two pieces, meaning it touches the graph, or it cuts the graph into two equal pieces. Hence you say you have axis of symmetry. This is the positive one, this is the negative one, this is the positive one. Even on this one, when the value of a is positive, it means our axis of symmetries are going to be on the side, meaning our axis of symmetries for x, for y equal to x, when it is reflected about y axis, then this one is when it is reflected about x axis. So this one is positive, this one is negative. How do you find these equations when you are only given this function? You're going to have y equal to x plus c for positive gradient. When is it positive gradient? When you say you want to determine the axis of symmetry that is positive, with the use of positive gradient, you apply this equation for negative gradient. You apply this equation. How do you apply it? Perhaps you have y equal 2 over perhaps x plus 1 minus 3. Then to determine the equations of axis of symmetry, both positive and negative. Then let's apply positive one. y equal to x plus c, ne? X plus c, simple, ne? For x you put in the value of p, for y you put in the value of q, you are done. Simplify for c, done. Then x is 1 here, then for y is -3, the value of p, the value of q, then you solve for c equals to -4, because -3 minus 1 is equal to -4. Then the equation is x is positive x minus 4, then you are done. This for a positive gradient. For negative gradient, you're going to have negative x plus c, -1 again. I mean, guys, here you say that when this thing comes out of this denominator, it's going to change the sign from positive to negative. It's going to apply even when you want the exact symmetry. Sorry guys, it's going to be -1 here, and here it's going to be -1 plus c, because when it comes out of this, it's going to have x plus 1 equal to 0, then x is equal to -1. That is our asymptote. Then also that -1 is going to apply here when you want the exact symmetry equation. You're going to have -1 plus c. For x, -1 plus c. So guys, you can please forgive me. The -3 plus 1 is -2. You're going to have -2 here. That's how you simplify it. So guys, but I hope you understand why I did mistake. Even here, x I want to guy -1 plus c, then our y is -3. Negative times negative is +1 plus c is equal to -3. So then you transpose this 1 to the side, is going to be equal to -4 equal to c. Then the equation is equal to -x minus 4. This negative, you won't change it, of x, you won't change it. You are done. Then you want to draw the graph of these two functions. And the same set of x's, but it should have these dots if you want, by the way. But up to so far, what I know that it should have these dots, so that it can show that it cuts the graph into two pieces, into two equal pieces. I hope guys you understand. Let's go to questions. Let's go to example number 1. Yes. So guys, number 1, it's so simple. You see that draw the graph of perhaps xy equal to 3 and show all the axes of symmetry. This is the question. So let's just draw the graph here. We have xy equal to 3. You write this equation in standard form here by making y the subject of the formula in this case. So we divide both sides by x to be left with y on one side, y equal 3 over x. Then you're done. The intercept x, intercept, let y be 0 here. 0 equal to 3 over x. Then when you cross multiply, what's 0 over 1 here? 0 times x is 0, 1 times 3 is 3. There's no solution for this one, meaning no solution, does not exist. We need a variable, not constants here. Then y-intercept we let x be 0, y equal 3 over 0. Even this one, there's no solution because a number over 0 is undefined. No solution. So you're done. Now guys, let's come back here. You can see we don't have intercepts, meaning our graph, when they touch our y-axis, there's no solution, meaning our graph will never touch the y-axis line and the x-axis line, because there's no solution in those positions. So we want to see our graph touching the y-axis and the x-axis line. Now let's come back here. Let's have a box. of x and y. Let's come to basics. X and y. When you don't know the shape of the graph, just come to this box. It will help you a lot when you need the shape, even if you have intercept. But for the shape, for the sake of wanting to know the shape of the graph, come to this box, guys. You'll get it right. This box will help you a lot. It even helped me during my times. -2, -1, 0, 1, 2. You basically give yourself x values from negative to positive. So you can give yourself -2, -1, 0, 1, 2, or -1, 0, 1. You are done. Or -3, -2, -1, 0, 1, 2, 3. You are done. Even from -5 to 5, you are done. Then you substitute. Where you see x, you put in -2, you find y on your equation. Yes. So you can just say 3 divided by -1. 3 divided by -2 is -3/2. 3 divided by -1 is -3. 3 divided by 0 is undefined. 3 divided by 1 is 3. 3 divided by 2 is 3/2. You are done. You draw the graph with this coordinates. Draw the graph with these coordinates. Simple. -2, -2, -3/2 is -1,5 perhaps. So it can be here. Yeah, here. -1, -3, -1 and -3 can be here. Then 0 is undefined, meaning you don't touch this line. Basically, 1 and 3 can be here. 3, 2 and 1,5 can be here. 1,5. Then you join the points. You already know that our graph won't touch the y-axis line, even the x-axis line, because there is no solution on those intercepts or on those axes. So let me just join the points again. Yeah, but guys, this is how we draw the graph of this function. Even this one, you just join it. Don't touch those axes here. Then you are done with drawing the graph. Now let's come to axis of symmetry. What's the positive one is y equal x plus c. Then you come here again. What is the value of p in this case? Remember, guys, when there's nothing, it's 0. Plus 0 plus 0. I mean, this is the value of p and the value of q. It's 0 and 0. There's no 1. 1 you find it when you only multiply. Yes, but when you add or minus 0 all the time, you cannot put 1 there, so it's 0. So where you see x, you put in p. Where you see y, you put in q. Yeah, that's simple. Yes, then let's go. For y is 0 equal to 0 plus c. Then c equals to 0. Then the equation, therefore the equation of x of symmetry when in a positive direction is equals to y x plus 0. You are done. Then the -1, number 2, y equal -x plus c. Obviously is 0, -0 plus c. Then y equals to -1 times 0 gives you, then equals to c. Then negative is then y is going to equal to x plus 0. Then done. You must draw the graph of this function and of this function in a dotted line here. Yes. Let's just draw without wasting any time. For this graph, you can just draw the box to see what the shape of the graph, but you know what this is reflected about the y-axis here. Whatever, obviously you're gonna just draw the graph of this function in this case. the graph is going to be like this, guys. Yes. I'm not good at drawing, so bear with me. Let me just draw a graph. I'm not good at drawing. I'm not good at drawing, but just bear with me, guys. That's how the graph will be shaped like. Yes. Then let's just draw the graph of negative x plus 0. Obviously it will reflect about x-axis. It will be like this, guys. I'm not good at drawing. Then you are done. You are done with showing the x of symmetry. Then you're gonna say y equal to negative x. Then y equal to x. Then, guys, you are okay. You're gonna get it right. Now let's just treat some questions. Let's just treat some questions. Yes. Let's just treat some questions in this case. Yeah. Or there's an equation you can use also, guys. Yeah. So there's an equation you can use, but let me just leave it because it's going to confuse you at some point for x of symmetry. But there are various equations you can use to determine the x of symmetry, the equation of x of symmetry. I'll just show you as time goes on. But this one is so simple. This is so simple because you just find the value of c, then you're done. Yes. So let's just treat some questions for a hyperbolic function. A few questions that requires our attention. Yes. Guys, let's just complete these questions. So yes, these questions are examinable. So I like such questions that challenges us. So number 1, consider the function f at x equal to 3 over x minus 1 minus 2. So it's a hyperbolic function here. There's no need for debate. Number A, write down the equations of asymptotes of f. Simple. So if the equation here, f at x equal 3 over x minus 1 minus 2. Number 8 is you see that you must write the equations of asymptotes of f. Asymptotes, guys. We have x and y asymptotes. Yes, vertical. This is a vertical, this is a horizontal asymptote. Simple. So for vertical asymptote, you come here only. You see that equation x minus 1 should equal to 0. Then solve for x is equals to 1. Then you are done with the vertical asymptote. All the time. This expression you must just equate it to 0 all the time. Then find for and solve for x. You are done. Then for horizontal asymptote, don't change the sign. So this negative 2 is gonna stay the same. Y equal to negative 2. You are done. Then number B. Let's come to number B. You see that you must calculate the intercepts of the graph of f with axes of symmetry. Remember, you must find the intercept and the equations of axes of symmetry. You are done, guys. Yeah. So x-intercept and y-intercept. X-intercept, you let y be 0. Let's just do it. 0 on the side. 0 equal to 3 over x minus 1 minus 2. Transpose it to this side. 2 equal to 3 over x minus 1. We cross multiply. 3 times 1 here is 3. Then 2 times x minus 1. 2 times x minus 1 again. Then 2 times x. 2 times 1. 2x. 2 times negative 1 is negative 2 equal to 3. We transpose it 2 to the side. 3 plus 2 is 5. 3 plus 2 is 5. 2x here. Divide this by 2. Then 5 over 2 is equals to x. Coordinates of x-intercept is 5 over 2 and 0. You are done. Then you have y-intercept, we let x be 0. Y equal to 3 over 0 minus 1 minus 2. 0 minus 1 is negative 1. then 3 over -1 is -3, -3 minus 2 is -5, then you're done. For needs of for intercept is -5. You are done, guys. Then axis of symmetry, remember you have negative and positive axis of symmetry. For negative is y equal to x plus c. For y you put in 1, and give what's y to our bracket, height to our expression in an outside our denominator, it changes the sign. The value of p changes the sign from -1 to +1 when it comes here. Yeah. Then the value of c, we want it, then y I want like -2, then you are done. Then we have 1 plus c, y I want is -2, yeah, our q. Then solve for c equals to -2 minus 1 is -3, then you are done. The new equation of axis of symmetry is x minus 3. Then for negative direction or negative gradient is -x plus c. Then whatever, this one also is going to come out positive, but we have negative here, minus 1 plus c equals -2. The -2, I get it to transpose to the side to change the sign. -2 plus 1 is -1 equal to c. Then y equal to x minus 1. Then you are done, guys. They just said you must calculate x-intercept and y-intercept plus the x-axis of symmetry. Then you are done. We are now coming to the third question. Number C, sketch the graph of this function. Sketch the graph of f. Let's just sketch the graph, guys. Simple. Number C, sketch the graph. Number C, you sketch the graph. Sketch the graph of this function. Yes, so we substitute our intercepts here. So 5 over 2, 2,5 here is perhaps on the side here. Then we have 0 and -5, 0 and -5, 0 and -5 on this side here. Perhaps our -5 is going to be, let's just say here. Then our asymptotes, remember our asymptotes, you must never forget them. Our asymptotes, they're the ones that will divide the direction of this graph. We have -1 and -2. I mean 1 and -2, sorry. Our vertical asymptote is 1, meaning coming to the side 1. We just draw a scattered line 1 here, perhaps. Yes. We have 1. Yeah, 1 up until infinity. Then we have -2. -2 horizontal can be here. -2 is not a problem. Can be here -2. Then let's just simply draw the graph of this function. So you know, don't touch this horizontal line, don't touch this vertical line. Simple. I just showing it, guys. Yeah, guys. So sorry for just drawing this vertical line. Let me just sorry guys, let me just join this point so that you can just see where it will end. Sorry for just drawing a shorter y-axis. You see, guys, I mean this graph, it will just pass next to this dotted axis here, our asymptote. I mean, you don't touch these asymptotes, you just pass next to them. Yes. Then for this one, let me just draw the graph of this on this part. I'm not good at drawing graphs, but ngiyazama nje, guys. Up until infinity, and you are done, guys. Let's just label. Okay, before we label them, let's just draw our axis here. Meaning we must draw the graph of this function and the graph of this function, our axis of symmetry. Yes, let's just draw them. But if you don't know how will the graph look like, just draw the box of y and x value, that just like we did in the previous example. Just draw the x and y values. You give yourself the x values, then you draw the graph. Simple. But now I'll just draw the graph with the use of intercepts. But if you don't know how to draw the graph for these straight lines, just use that box. It will help you a lot. Or just find the intercept, and it will help you a lot also, guys. So let's come here. X minus 3. X minus 3. And here we have y equal to x minus 3. For x intercept, let y be 0. Then 0 equal to x minus 3. Then transpose to the side 3 equal to x. Then 3, then 0. Then you have y-intercept, y, let x be 0. Then y equal to, for x minus 3, and for this one, 0 minus 3 is equals to negative 3. Then you are done. You have 0 and negative 3. Let's just join these points. 3 and 0, you are on this side. 3 and 0 on this side. Here. Yes, on this side. 3 and 0. Then we have 0 and negative 3. 0 and negative 3 can be here because this point is negative 2. So negative 3 can be here. Yes, negative 3 can be here. Yeah. Then you can just join those points. Yes, guys, so let's just join these points. I'm not good at drawing, but just how much. Let me just draw the graph. Guys, ngiyazama bese ngijone correctly ngiyibona guys. So the graph will look like this. This one is of y equal, x minus 3. Let's just draw the graph of x minus 1. This one, let's just do this one first. Yes. So let me just find the intercept here for x minus 1 here. Sorry guys, I don't have space right now, but I'll just try to draw the graph of this function x minus 1 here. Then x intercept, let y be 0. 0 equals to x minus 1. Then x equals to 1. The intercept is 1 and 0. Then for y intercept, for y, we let x be equal to 0. Then yes, for 0 minus 1 is equals to negative 1. Then we have 0 and negative 1. Let's just plot those two coordinates. Do you see, guys, on this annual graph? So 1 and 0, 1 and 0, 1 and 0 can be on this side here, but 1 and 0 can be here. Remember our vertical axis is 1 here, 1 and 0. Then we have 0 and negative 1 is 0 and minus 1, it can be here also. Yes, here we have 1 and 0, then we have negative 1 and 0 here. Then yes, let's just come back here, and I think I made a mistake. Let me just show you my mistake here. So let's just come back here, guys. Here, remember this x, it has got negative here. This is a negative axis. This x has got negative here. That means it will carry this negative up until here. So I didn't put in this negative here, guys. Sorry. Hence my graph I thought I'd not make a mistake, but my graph would not be this graph should be our reflection. This graph, it shows it will just pass this. It's also like this. It's wrong. It's wrong, guys. So let me just copy it. Can I please fix the mistake I made here, guys? Yes, let me just fix the mistake I made. Let's come back here. I just found the intercept for this function again. I mean, yes, the intercept for this function of y equals to negative x minus 1 again. So we have negative x minus 1, then negative 0 equate to the going to be positive 1, then we divide both sides by negative x, or negative 1 is going to be equal to negative 1 here. Even on this one, you're going to have yes, it's correct if it's like this. So we're going to have negative 1 and 0, and 0 and negative 1. Negative 1 and 0. Let me just use a different color. Negative 1 and 0. It is here, perhaps. Yes, it's here. Then 0 and negative 1 is correct. This one is okay when it's on this point here. Yes, guys. So the aim is you should touch this intersection of the asymptotes. That's the aim. So that's the aim. Yeah. So guys, for the mistake, yes, I won't repeat the mistake again. I will make sure of that. Sorry. I guess my point is going to be here. Sorry. So guys, yes, I think this is how the graph will look like. Yes, I think this is how the graph will look like. Yeah, this one is correct, guys. So can you please just remove this coordinate here? You just draw it yourself so you can see good here. Where did I go wrong? So you can see good. Yes, I didn't make a mistake here. So this graph is now y equal to negative x minus 1 again. Yes, guys. Yes, guys. So sorry for the mistake I did. Hopefully next time, in the next example, not make a mistake when drawing the graph of this function. Yes, guys. So now let us go to the next question, number D. Yes, number D. This is how this should look like. It should cross, or should, yes, it should cross this point. It should intersect at this point of asymptote. If it does not, if they do not intersect, that means there's a problem somewhere. So I'll just draw it correctly. Sometimes I will just draw another graph in the correct way. So sorry guys, sorry for the mistake, guys. Sorry. Yes, let's just go to the next example. Yes. So guys, number D, they said we must write down the range and domain of f. Simple. Domain and range of this function. Domain is all x values that are real, such that, remember, for domain you just check just come here, here you're gonna say x minus 1 should not be equal to 0, meaning this graph should not touch, meaning when this graph touches 1, the value of p and r is equals to 1, our asymptote is equals, vertical asymptote is equals to 1, meaning our graph does not touch that line. Hence we're gonna say x should not be equal to that line. What is the value of that line? Is 1. That means x should not be equal to 1. Then you are done with your domain. Meaning our graph should not touch that line. Y x equals to 1. Then our range, the one is so simple. Y is the element of real numbers, such that also you come back here. Y should not be equal to this. Our value of q, the horizontal asymptote. We are done, guys. Y should not be equal to negative 2. Then you are done with your domain and range. Number E, write down the range of y equal to negative f at x. The range of y equal to negative f at x. The range, simple. Here we have f at x here, then we have negative. Just let's put this negative. Then what is f at x? What is f at x? Let's compare. What is f at x? Here's f at x. You put it this equation, all of it, where you see f at x, you substitute it basically. So you're gonna have 3 over x minus 1 minus 2. Then you close the bracket. You multiply this negative by each term inside the bracket. Then negative times x minus 3, negative 1, invisible 1 again, multiplied by 3 over x minus 1 again, minus negative 1 multiplied by negative 2. Can you see, guys? This negative 1 is going to multiply this bracket, this term. This negative 1 is going to multiply this term again. That's how we'll go. Yes. So guys, it's going to be plus here because I've got negative, meaning positive times negative is negative. Come back here, or we can just say negative 1 times negative 2. We're still okay. Yes. Then negative 1 numerator by numerator. Negative 1 times negative 1 times 3 is negative 3 over 1 times x minus 1 is equals negative x minus 1. Negative by negative is positive, plus 2. Then you are done. You are done, guys. This is the equation of this function. It's plus here. Then the range. I just must say, they must determine the range of this function. The range, all y values that are real here, such that, remember, range for the value of q, y is not equal to 2. Then you are done. Then f. So guys, for the mistake I did here, but it's not a mistake, but when I take out, when I work with signs, meaning if I introduce bracket, that means I'm gonna change the sign for this one. It's going to be plus, because when I multiply it, positive by negative, it's going to give me negative. Or you can just automatically say negative 1 times negative 2. You can just automatically say that negative 1 times negative 2 is going to give you positive 2. You are done. Or you can just do this, not a problem. I just want to apply step by step principle. Yes. Number F, write down the range of y equals to 2 times f at x. Range of y equals to 2 times x. Y equals to 2 times f at x. Range of this 2 multiplied by, what is f at x? 3 over x minus 1 minus 2. This 2 is going to multiply each term inside the brackets. 2 times this is going to be equal 2 times 3, 6 over, and here we have 2 over 1. 1 multiplied by x minus 1 is equal to x minus 1. Then 2 times negative 2 is minus 4. Then you are done. Then what's the range of this function? The range is such that y is the element of real numbers, such that y should not be equal to minus 4. The range is for the value of q. Then you are done, guys. Then let's go to g. G is so simple. G is so simple. I hope you guys still understand me. So just pause the video if you don't understand, or just come to this comment section and ask for clarification. Yes. So number G, write down the domain of y equals to f at negative x. Number 2, y equals to f at 3x. Yes. Let's do the domain of that function. The domain of that function when number 1, they say when y is equals to f at negative x. In this case, guys, you're going to substitute where you see x, we put in negative x. This negative sign has implicated x, meaning where you see x, you put in negative. Simple. From this equation. Let's just do that. F is equals to 3 over negative x minus 1 minus 2. Our guys, simple. Then when I say 3 over negative x minus 1 minus 2, then you are done. Domain for this function is x is the element of real numbers, such that you put in this thing, you're gonna say such that negative x minus 1 is not equal to 0. It's all for x right now. The negative x is not equal to 1. Substitute. I I transpose this negative 1 to the side, it's going to be positive 1, then I divide both sides by negative 1, then x is not equal to minus 1. This is the domain, guys. Domain is all x values that are real such that x is not equal to negative 1. Yeah, done. Simple, ne? Then number 2, you can apply this step in any question that involves the domain of any function of hyperbola by just saying that value, or that our denominator should not be equal to 0. Then you just apply basic methods of solving for x. You are done. Number 2, they say that when y is equal to f at 3x, guys, because x is implicated, meaning you're gonna substitute 3x where you see x. Simple, ne? Y is equals to 3 over here's x, you put in 3x where you see x, minus 1, minus 2, then you are done. Domain, you come back here again. Domain are all x values such that 3x minus 1 is not equal to 0. So for x in this case, 3x is not equal to 1, then divided by 3, then x is not equal to 1 over 3. This is the domain, guys. Domains are all x that are real such that x is not equal to 1 over 3. Then you are done with the domain of that function. Let's go to the next question, H. I hope you understand, guys. So if you don't understand, just come back to me on my comment section or my email, even my WhatsApp numbers. I'm available. Even on Facebook, I'm available for questions like this. Yes, let's come to the next question, H. Guys, then H says that write down the new equation of asymptotes of the following. This one is so simple. Let me just it says that you must write down the new equation of asymptotes of the following if f is shifted 2 units to the right and 1 unit downwards. And here number H say that 2 units to the right, to the right, and 1 unit down, then 1 unit down. Simple, ne? Remember, and they must write the new equation of asymptotes for the following. I just y equals to 3 over x minus 1 minus 2. Then remember, this is the vertical asymptote, this is the horizontal asymptote, meaning for the right you must choose here, for the downwards you must come here. Simple, ne? Simple, ne, guys? Yes, let's just do that, guys. Yeah. So guys, let's just come back here. So and you want to see about when you look at this expression, this is our vertical asymptote. So vertical asymptote in terms of 15, vertical asymptote in terms of 15, it goes from left to right. Then our horizontal asymptote obviously goes up and down again. Horizontal asymptote, it moves from up to down, vice versa. Yeah. So for the right you must focus on the vertical, you must focus here. For up and down you must focus here. So 2 units to the right, 2 units to the right. Let's come back here. 2 units to the right, left to right, or right to left. It's vice versa. So let's come back here. We need to talk about left to right, vertical asymptote. So let's have the equation x minus 1 here, 2 units to the right, meaning this negative 1. Remember, when it comes out of the bracket, it's going to be positive 1 here. So let's treat it as if it's positive 1. Let's treat like that. But in this case, when I say x minus 1 minus 2 equal to 0, and you must write the equation here for those asymptotes. Yes, x minus 1 is equals to 0. Then x is equals to negative 1 minus 2 is negative 3. Then x is going to equal to x is going to equal to positive 3. And yeah, because 2 units to the right, it goes to the positive side. Hence we say negative 2 here. Or in your own space, you can just say, okay, now we have negative 1, you know good when it comes out of the bracket, it's going to be equal to positive 1. Hence, and the first time you got x equals to 1, and when this thing comes out of this some comes out of this equation, and you got x minus 1 equals to 0, then you got x equals to 1, and this is the initial equation, this is the initial vertical asymptote you got, and now they said you must add 2 units to the right, meaning we go to the I can draw the number line again. What's about negative infinity or positive infinity? Hence we say we add 2 to this side, meaning this graph and our positive one nearly more here. Then when you see that you must 2 units to the right, it means you go to the positive side, meaning you must add from 1 to 2, and the one is going to equal to positive 3. Hence we're going to say 1 plus 2 equals to 3. You can just do it in this way or in this way, but if you do it in this way, you must make sure that you say negative 1 minus 2, so that the final answer should be positive, so that the final answer should not be the same as this one, so the final answer should correspond with the graph, with the function where it shifts here. That's how we do it, guys. Then for our horizontal asymptote, it's so simple, y is equals to minus 2, and then that's it. We are 1 unit down, 1 unit down. Remember what's about vertically, what's about this is our positive infinity, this is our negative infinity here, meaning this is our positive side, this is our negative side, meaning when you add 1 unit downward, meaning we're going, we are decreasing basically, meaning from negative 2 we add 1 from negative 2 is going to equal as negative 3, and minus 1. When you go up, you say plus 1. When you go down, you say minus 1. When you go to the right, you say plus. When you go to the left, you say minus here. But when you say to the left here, you say plus 2. Simple, ne? Then the answer is equal to negative 3. Then you are done, guys. You are done with this one, ne? You are done, guys, ne? Yes. I hope you understand. Let's go to number 2. There are many questions there. Number 2 says that shifting again, ne? Number 2, if f is shifted 2 units to the left and 1 unit upwards, 2 units left, 1 unit up. Remember, 2 units left, you come back to this one. Lefty, what's right again to the vertical and asymptote. So let's have it x minus 1 again. 2 units to the left, remember you add, and now you add now. You say plus 2 equals to 0, ne? Because to the right you minus, to the left you plus, yeah, vice versa. But when you come here, you say 1 minus 2, and yeah, simple. I hope guys you understand, ne? So let's come back here. So x is equals to, x 2 minus 1 is plus 1 equal to 0. Then x equals to negative 1. Then you are done. 1 unit up, you focus on the horizontal asymptote. Y is equal to negative 2. 1 unit up, you add and get plus 1. Then y is equal to negative 1. Then you are done, guys. Simple there. Then the last but not least, number I. Number I. Even if, I'm sorry, guys, this is the last question, by the way. So you must write down the new equation for the following: if f reflected across x-axis and y-axis. Remember, so simple, ne? Remember, let me just explain something. Y-axis, when you have coordinates x and y, if they must just reflect across y-axis, meaning your x should be negative, basically. Thank you. If they say that you must reflect across y-axis, your x will be negative, ne? Simple, negative x and y. If they talk about x-axis, your y should be negative, and if you have something like this, your y should be negative x and negative y. Correct me if I'm wrong, guys, but this is how we do it, ne? Let's come back here now. Let's come back to our equation, this equation, ne? Let's come back to this equation. Let's reflect this equation here about x and y-axis. And here we have y equal 3 over x minus 1 minus 2. Ne? Now, they said it must reflect about x and y-axis. And here for x-axis, let's put in negative where we see x. Simple. Negative where we see x. 3 over negative x minus 1 minus 2 equals to, simple, ne? You can just say 3 over negative x minus 1 minus 2. This is reflected about y-axis. Then let's come to x-axis. We put in y where you see, y, you put in negative y equal 3 over x minus 1 minus 2. You want where we see we want the positive y, not negative y. You divide both sides by negative 1, basically. Negative 1, then y equal to 3 over x minus 1. KFC, keep the first changes and flip the second, multiplied by, whatever is divided by negative 1. Me, I'm gonna flip, and here we have negative 1 over 1 here. Then this one is going to be my numerator, then my negative 1 is going to be by denominator, 1 over negative 1. Then negative 2 divided by negative 1 is positive 2. Then 3 times 1 is 3. Then negative 1 times x is negative x. Then we have negative 1 multiplied by negative 1 is positive 1. Then you have plus 2. This is the function when it is related about x-axis. Then you are done, guys. You are done. Yes, guys, I hope you have captured something new or some sort of concept that you have never got an explanation for it. For today's section, we are done for now. Next time when we meet, we're gonna explain exponential graph and its inverse. After that, we're gonna explain inverse of parabola, many to one, one-to-one function. Is it function or not? Those stuffs. Then after that, we're gonna along the week, we're gonna just simplify questions. That involves functions, questions after questions, example questions also. So then from Monday, you're gonna start with question papers. We're gonna deal with question papers from question 1 up to the last question. Basically, so ungasabi, you are still here on this channel. Subscribe and like, comment. We get more content of mathematics as we're about to write maths next week Friday. I hope you gonna enjoy your Sabbath Saturday. Enjoy it, guys. We're gonna meet when you do exponential graph in the next few hours, basically. Yes, thank you very much. Enjoy.